Hey, it's Let's Make, and this is my university dissertation. So this was my final year dissertation project. It's an after disaster robot, so it's what would be used to go into the field when there's been a disaster, like it could be a man-made disaster like a nuclear reactor going wrong, or it could be natural disaster, for example a tsunami or an earthquake. So you'd use these instead of sending people in because it's safe and you want to check out the place first, the environment, what's going on, and not risk any more lives. So yeah, I've designed this completely, fully myself, except for the tracks, which I got from Thingiverse. The credits are on my dissertation, so you can find that in the link below. The rest is designed by me, so I'll just go over each part and what it does. So the first thing you'll notice is these solar panels. This is completely designed to unfold. So in fact you would get more space or more solar panels in a small amount of space. When it's fully gone down, it's wider than the actual tank itself. And this part makes it charge a bit better. So that's the first thing you'll notice. It will has two buttons on either side. These are limit switches, so that it knows when to stop. They're quite useful. They're cheap as well. Total hours of printing was over 100. If you include design as well, and electronic design as well as the software design, it's definitely over 300 hours of work. So these are 5 volts each. And they're done as 3 in series, 2 in parallel. So they're quite useful. Then it's designed also to be able to take apart and be fully modular, in the sense that these slide off like so, and you can access the insides. So the next part you'll notice is this bit. So this is the sensor box. It's got an ultrasonic sensor at the front. Inside it's got temperature and also reads different gases like carbon dioxide, carbon monoxide, nitrogen, etc. Then we've got the camera, so you can control it remotely and be able to see. It's got 2 servos, one to go left and right and one for up and down, so that's pan and tilt. The camera itself is for the Raspberry Pi. It's got infrared on it, which makes it useful in the dark. So then how is it controlled? It's got 4 motors, which are each 12 volts each, one in either cog. And then we'll take it apart so you can see the inside. Both sides come off. So we use NEMA 17 motors for the solar panel unfolding. These come off. It will stretch. So there's different boards internally. So here's an Arduino which controls the motors purely. So this is for this is the motor driver to unfold the solar panels, limit switches for the solar panels, and it controls also the pan tilt for the camera, and it has another internal temperature sensor. So then we know what it's like inside the vehicle. So once that's apart, let's take a look inside. Okay, so the first thing you'll notice is the Pi. So a lot of mess with the wires, it needs to be tidied up. Currently it's not in a working state because I had to harvest different bits for other projects. So it's a Raspberry Pi 4. That's got the main system on, which you use VNC viewer to get into it, and then you control it via that and a Python script. That way you can control what happens to the wheels, where it's going direction wise to unfold the solar panels, and see all the data we're getting in. We have 2 dual 2 amp motor drivers here, one for each side, so that controls these 2, this one controls these 2. Then we've got the main power board, which just distributes the power. So we've got 12 volts in, the battery normally goes here, 12 volts in, and then we've got 12 volts for these 2, underneath here we have a little 12 volts to 5 volts at 5 amps to power the Raspberry Pi as well as the Arduino on the side. So next thing you'll notice is the Arduino, it's a big one. This is purely for the sensors, so it doesn't do anything else. Originally it also controlled the pan tilt and the solar panel unfolding, however it just ended up being too much processing for this little Pi, this little Arduino basically, so I decided to split it up into two instead. A bit unfortunate because this has so many inputs, but it can't handle serial very well. It's a bit slow when you've got quite a lot of serials going on. So this communicates with the Pi using USB and uses ROS, which is a robot operating system. And the coolest part, I think, is the neural compute stick too. So this is the Intel compute stick. It's a visual processing unit, which basically means it takes a lot of the load off the Pi when it comes down to any visual processing, which is what I used for the artificial intelligence side. So I had object recognition within the camera feed, so it would recognize if there's a human or a pet or some sort of animal inside of the camera feed. This is identified on what you see on the screen and will be highlighted with a box around it. The reason I chose this was because it's an after disaster robot, so you don't want to miss the chance that you might find a survivor or someone who's injured. You want to be able to identify this and see it, and the person controlling it might miss this if they're looking for something else. So using this processing unit, we're able to identify a person or a pet, since normally an animal will stay near their owner, especially in distress. So we're able to find that person, identify it, and notify the controller that, look, there's a person over there, go investigate. So that's why we chose the Intel stick. It takes a lot of the processing off the Pi, it also speeds it up. When it was the Pi itself, I had about maybe 8 frames per second, which is ridiculously slow, but with the stick added on, it's able to go a lot faster, around about 15 to 20 I think I had at max. So yeah, it's perfect for that. Fully modular. So the reason I chose fully modular was basically I wanted to prove that you could build a robot under £1,000, as well as being able to just 3D print and add new parts if you needed to. There's obviously a lot of ports here free which you could add to, and with these being interchangeable, you could just change the top. So whether you want a robotic arm instead of a sensor here, you could add that quite easily. So the main objective was to prove that you could build a fully modular after disaster robot, which has obviously smaller lead time to build in, also for a cheap price, so like an affordable price. I had a look online and you see these other robots, and some companies spend millions of pounds in research and design and research and develop just for these types of robots, and this one in total cost me, for all the parts, filament, and electricity for printing, it cost around about £811, which for a university project is, I'd say, quite reasonable, although I wasn't reimbursed, so this is kind of annoying that it came out of my pocket. But I liked what I built because I found it really cool. It was fun to design, to learn all these new parts, and I really wanted to combine artificial intelligence with the robotics, which is what my course was. A lot of other students focused either on purely artificial intelligence or purely robotics, so I felt this was a good balance, as well as proving that it could be useful in real life concepts. Software wise, the software could definitely be improved. It's running on a Raspberry Pi, simple Python script. We're using a simple like GUI. Tkinter is the one I used. This is a bit basic. I didn't spend much time on creating the software because I was focusing more on the mechanical sides of parts, getting these to work. the solar panel unfolding, all the electronics, a good power distribution, and where to lay out all the parts, as well as fix them in so they don't fall apart. So yeah, so it could be, the software could be improved. Like I said, I can't show you a video of this working right now because I haven't got all the bits and I've taken a bit apart. However, I do have a video which I recorded for my dissertation. It's atrociously filmed, so please don't judge, and I'll show that now.